Hello, ladies and gentlemen, welcome back. Last time we figured out what is an input. This time around we're going to figure out what is an output. So input is where the energy enters the system. So then you can probably kind of think about what an output is. And remember, with this, we're talking about mechanical systems. So that's what our theme is, mechanical systems. So things like machines, they have moving parts, and I like to use the word guts. There's these different mechanical parts that move and so on. So inputs and outputs. And then we're eventually going to worry about the different types of motion. There's 3 different types of motion. And then the reason why we're learning these words, like trying to learn them really in depth, is because the better you understand input and output, and the better you understand the 3 types of motion, most likely the better you'll be able to design and then build your devices. For example, in class, most of the classes will be building a pull toy. So in order for you to be successful with that, you got to really understand these different types of the vocabulary, these words, which are really kind of big concepts. So input, where the energy enters the system. So think about right now, what do you think would be the definition of an output? So the definition of an output, most people were probably thinking it's where the energy exits the system, because if an input is where the energy enters the system, an output would be where the energy exits the system. We're going to start with that. That's definitely a very good start. So what I need you to do, I'm going to need you to pause in a second here, and you're going to have to make another word web and get yours set up. So here's what you got to get set up on yours. So just like you did our other word webs, you got the word in the middle. This time around, we got output, we got our definition underneath, use it in a sentence, examples, and picks. So for your examples, we're going to use the same examples that we used last time. We're just going to add this time, though, what the output is. So get your bicycle on there, get your phone pull toy on there, get your vice, clapping monkey, egg beater, jack in the box. Get those on your list. For your picture, we still got a picture of the bike. Whereas last time we had a picture and we pointed to the input, this time around we'll point to the output. So get your picture set up there. And then I'm going to add my definition as well. So pause now, get set up. For input, we had you think about a pencil sharpener. And I think many of you realize when you think about a mechanical pencil sharpener, like one that you would find on the wall in a classroom, when you crank it, then stuff starts happening within that pencil sharpener. So that must mean that the crank will be the input of that device, and you would be 100% correct. So now thinking about our definition that for output, so think about our definition for output where the energy exits the system. If you think about a pencil sharpener, well, the energy exits that pencil sharpener through the blades. So those blades spin, and then that's what sharpens your pencil. So if you're thinking about a pencil sharpener, the output would be the blades and the pencil sharpener. Now, let's think about a bicycle. And what I want you to think about, and you're going to answer here, is what is the output on a bicycle? Now, this is really kind of a tricky question, and this is where we have to go a little bit more in depth about this. When you think about a bicycle, you think about what's the purpose of the bicycle. Well, the purpose of the bicycle is to travel forward. You want that bicycle to travel forward, and then you can steer it and turn, that kind of stuff. So the main output of the bicycle is going to be something related to that bicycle traveling forward. So some people might say the output of a bicycle is that the bicycle moves forward. That would actually be an incorrect answer. Imagine you flip that bicycle upside down. So the bicycle's upside down. Is that bicycle still considered a bicycle? So I'm hoping you're thinking yes there. And then now imagine you start pedaling that bicycle. And then think about what happens. Is that bicycle it's definitely not moving forward. So we have that bicycle, we flip it upside down, we're pedaling it, and then something that's happening is, well, the chain's moving, the pedal's moving, the rear wheel's moving. So if we think about the output being an action, or like a desired effect, like the bicycle moves forward, well, that's not correct. We're going to come back to that. We're going to let that simmer a little bit. Now, another answer that some people often say is, well, the output of a bicycle is wheels. Okay, so if we think about that again, Now, when you ride the bicycle, both wheels definitely start moving. But think about it again. You flip that bicycle upside down, you start spinning the pedals. Which wheel starts moving? The front definitely is not going to. So that must mean that the wheels, as in a multiple, that would not be correct because both wheels are not spinning due to the input. Because we still need to be thinking about the input and what is that input causing. So another answer that some people will say is they'll say, hey, the output of a bicycle is the chain. Well, the chain's definitely moving, and we want it to move, because if it didn't move, then we wouldn't get the desired output. What the chain really is, the chain is in between. The chain is an in-between system. It connects the input to the output, so then we can get the desired motions, which then causes a desired effect. So the chain is like an in-between thing. The chain would be something like I'd call the guts. It's like an in-between thing that it's just necessary to allow the output to happen. So the proper answer for what is the output on a bicycle. We're going to have you try it again. So the proper answer for what is the output on a bicycle is definitely 100% the rear wheel. Again, flip that bicycle upside down, pedal, that rear wheel is spinning. That must mean, so the input, so we put energy into the input, the pedals, and then the energy comes out at that rear wheel. So that's why that rear wheel is the output. Now let's think about our definition though. Our definition says the output is where the energy exits the system. So this is where we have to be careful, because when we pedal the input, I want you to think about that. Let's pedal that input really fast, and then imagine what you're hearing. You're hearing that chain bzz, or buzzing, or the tire moving around, whatever like that. You actually hear some sound. Now think about it. Is sound energy? Well, it is. So sound is exiting the system. So then would we say sound is an output for this device? Is sound something that we want to happen for the bicycle? Is the reason why you ride your bicycle so you can listen to that really cool chain, so you're pedaling away, you're like, man, yeah, that chain sounds awesome. That'd be kind of weird. So I'm going to assume you don't ride your bicycle to really listen to that chain. So this is where we have to modify our definition a little bit. When we have mechanical systems, we have other things that are given off, other types of waste energy. For the bicycle, sound would be an example of a waste energy. We don't ride the bicycle for sound. So we need to change our definition. Here's how we're going to change it. So add this to your word web. The output is where energy exits the system and causes, it causes the desired effect. It's like the purpose of the machine. So I fixed up my definition. You do the same to yours. We got to be nice and specific. So where an output is where the energy exits the system and causes the desired action / purpose of the machine. So it's where the energy exits the system and causes like the desired action. It's like the purpose of the machine. I also wrote my sentence, so I used output in a sentence. My sentence is, the output of a bicycle is the rear wheel because the energy exits the system there and is desired. So you have to write a sentence using the word output as well. So you can pause here if you need to see my stuff. All right, let's do a couple examples, and then this one's done. So think about, we got these different devices here. So I'm going to put a question for each one of these, and your job is to figure out what is the output for each of these, and we'll see how you do. For this vise tool, the output is definitely the clamps closing. That's the desired action. It's not the sound. We don't care about the sound, but the clamps are closing. That's desired. We want that to happen. That's why the output, the clamps closing or opening if you turn it the opposite way. The output of the phone pull toy, it actually has a couple. The big one is the eyes moving. That one. definitely is one of the main ones. That one's easiest for us to see. And then the other output would be that we actually want sound. We want this thing to be making sound. So another output you could argue is sound in this one. The output of the egg beaters would be the whisks spinning. The output of the creepy clapping monkey, you could say it a couple different ways. You could say the arms themselves, or the cymbals, which are connected to the arms. And then you could argue that the sound that this makes as well, the sound is kind of a byproduct of the output. But you could kind of argue either way. And then the jack in the box, the output would be the jack popping out. And then you could also argue that another output, so it has two outputs, the other output would be the sound that it makes, makes like a little song inside of it. So anyway, that's output. And the next videos are going to be about the different types of motion, and then identify the different types of motions for these inputs and outputs. Thanks for participating.